Hello, my lovely students. So we are back with the next part of 2A. This one is on simplifying fractions. My apologies for not posting it sooner. It's been a long couple of days with my daughter, but I'm doing it now and I'm going to post some extra so then we're ahead, hopefully. All right. So the first part is factorization and divisibility. Two numbers multiplied to form a product. 2. That should be TWO, shouldn't it? Two numbers multiplied to form a product are called factors. Example, 2 parentheses 3 equals 6. So that's 2 smushed onto 3 means 2 times 3. So since 2 times 3 is 6, 2 and 3 are factors of 6. Factors are whole numbers. So certainly any fraction we can think of another number to multiply to the fraction to get us to whatever other number we want. This is what whole numbers can be multiplied to make up the larger number, usually larger number. It doesn't have to be. The number itself is a factor of itself. And then when we multiply two numbers, we call that a product. So a factor has to divide, we say evenly, that can sometimes have a mixed connotation. We don't mean that the result has to be an even number. We mean that it divides and there's no remainder. So I like to say divides nicely instead of evenly. But that's what that means. No remainder. Okay. So two different factorizations of each number. I'm going to assume this means two different pairs of numbers, not the same pair flipped. So with every number, including prime numbers are numbers that only have itself and the number 1 as factors. Nothing else divides nicely into it. You always get 1 in the number itself. That is always a factorization. It's kind of like the boring, but it's also like a gimme, so yay. So 1 times 15, 1 times 40, 1 times 28, 1 times 96. But that's a little boring. So 15, we just got 1 times 15, and then it's not even, so it won't be divisible by 2. So 3 does go into 15, 5 times. And then 40, well, that one's even, so I know it's going to be 2 times something. And what I do on the calculator to figure out what numbers divide in there, what the factors are, I just start with, is it even? Okay, 2 goes into that, what do we get? In this case, 20. Then I'd go back to 40. Is it divisible by 3? No, but 4 it is. So 4 goes into 40 10 times. Ends in a 0 or 5, so 5 is going to go in there. 5 times 8. And now notice the 5 and the 8 are really close together. Once it kind of like, I think of it as like wrapping around, but basically once there's no more numbers in between, so we'd check 6 and 7, neither of which divide nicely into 40. That is our complete list of pairs of numbers that multiply to 40. So there it is. Now this is a skill that pops up in algebra. Your brain might be remembering having to do this to factor quadratics. As far as I can tell, we're not actually going to factor quadratics in this class, but this was one of the many crazy steps you had to do that. And if you want to know more about that, please come to office hours and ask me. I've got multiple methods. So 28 is even, 2 times 14. 2 plus 8 is 10. 10 is not divisible by 3. So this is not divisible by 3. That's what the divisibility rule for 3s is down here. You add each of the digits, ignoring place value, just the actual numerals. And if the result is divisible by 3, then the number you have is divisible by 3. Likewise, if the result, when you add them all together, is divisible by 9, it actually means the number is divisible by 9. And that is just a peculiar feature of the base 10 system. Because of the way base 10 works, We can add all the digits, and if they are divisible by 9, it's divisible by 9. And then because 3 is a factor of 9, we can make use of that for 3's. But it truly is just a weird fluke because we use base 10. And if you were wondering, this is why. Because we have 10 fingers, counting the thumbs. But 4 does go in there. 4 times 7. Now, sometimes I start to think of this, what we're going to do with prime factorization. So like 1 and 28, I'm not as comfy with, but 2, and I can kind of reason through. 2 will go into 2 once, 2 will go into 8 4 times. So I got 14. 14 is a little more comfortable. I know that. That's 2 times 7. So I don't want to write 2 times 2 times 7. Although we could, but usually when they ask for this, they want pairs of numbers as factors, not more than 2 numbers. But technically, if we didn't limit ourselves to a 2-number factorization, we could write 2 times 2 times 7. But I just think of it as 2 times 2 times 7 or 2 times 2 times 7. And that gives me the 4 times 7. So I just kind of think of it as this number is made up of a 2, and a 7, and I'm just grouping the numbers together in different arrangements so I get different pairs. Any other arrangement is going to arrive at 4 times 7 or 2 times 14, or if we lump them all on one side, 1 times 28. 96 is a lot more interesting though. That is divisible by 3 and it is divisible by 2. So I'm going to go with the 3 actually because I can. All right, I know it's going to be 2 times something, but I'm going to go to the 3 first to try to figure out what it is. So 3 goes into 9 3 times, 3 goes into 6 twice. Oh, okay. So it is 3 times 32. 32 is 2 to the 5th power. 2 times 2 times 2 times 2 times 2. 5 2's being multiplied. So that means if I pop one of these 2's off, that would be 16, and 3 16s is 48. That is the way my brain works, but legit, you can crunch this on the calculator. You do not have to do this by hand, at least not for me. So since 32 is a whole lot of 2's, we're going to get a whole lot of 2 numbers. So 4 is going to go in there. The 8 times 3 is 24. 5 will not, but 6 will, because 2 and 3 will, so 6 must. All right, so that's a 2 and a 3. So one of the 2's off here would be 16. So 6 times 16, 7 will not, but 8 will. So that is 3 of the 2's from 32. So 2 of them would be 2 times 2. 4 times 3 is 12. We do not have 9 because we don't have a pair of 3's. And then 10 would involve a 5 and 11 is prime. So we are done. Those 6 are the complete list of 2-number factorizations of 96. It only said find 2 different ones, so we could have stopped after 1 and 96 and 2 and 48. I was just putting the whole list to give you guys a feel for this is how you could produce the whole list. I do it this way. Like, remember, I was like, I want to start with 3, but I still went back and I put the space for 2. That way my numbers are in order. So that way I know my last pair, I only have to test the numbers in between that pair. So I just went through the list. 1, 2, 3, 4. I skipped 5. Then I did 6. I skipped 7. Then I did 8. And then I considered 9, 10, and 11. And 12 takes us to a number on the other side of the list. So we are done. Can be a little more tedious doing it by hand, like crunching all the numbers. But in this case, a lot of them work. So it's not too bad. To speed that up, though, what we're going to talk about now is we're going to make visible the kind of gut instinct rules you probably already know. You just know them without knowing you know them. So the first one is divisibility by 2. We call this even numbers. So if the digit in the ones digit is even, then the number, regardless of what all the other digits are, as long as the last one is 0, 2, 4, 6, or 8, it will be divisible by 2, guaranteed. Divisibility by 3, I was talking about that earlier, It's divisible by 3 if the sum of its digits is divisible by 3. So the example here is really nice for this. 714. So 714, but we're going to take them as a 7, a 1, and a 4, not 710 and 4. But 7 plus 1 plus 4 is 7 and 5, which is 12, or 8 and 4, which is 12. 12 is divisible by 3, so 714 is divisible by 3. So this way you don't have to try it on all the numbers. And a lot of these divisibility rules are hearkening back to the days of our parents/grandparents when they didn't have calculators that used solar batteries. They had slider rules. Any rule like this, so you didn't have to manually check, does 3 go in there, was a lifesaver, because that was a whole long division problem you didn't have to do. Divisibility by 5. A whole number is divisible by 5 if the ones place digit is a 5 or a 0. This should be something you got used to as you were learning your multiplication facts, like just the way numbers go together, hopefully. And then divisibility by 10 is a combination of the 2 and the 5 rule. So the 5 rule is either 5 or 0. The 2 rule only has the 0. So something is divisible by 10 if the last digit is a 0. Doesn't matter what the rest of the digits are, it is divisible by 10. There is not a nice one for 7. It's like the number. We don't like 7. Because it only works 1/7 of the time. The other 6/7 of the time, you get an ugly decimal. So because I don't like 7, I will use 7 on reviews. So I don't use them on tests because I can't use the same numbers. So if you see ugly numbers on test reviews, that is why I do that. Granted, we're only going to have a final exam review, but any sort of review thing, I tend to pick ugly numbers on the review. If you can do the problem with the ugly numbers, you can do the problem with the numbers that aren't so ugly on the final. And a lot of teachers do that, some without realizing. All right, so now we are going to determine if these numbers follow the divisibility rules. Or, well, they follow them, we're just going to label. So let's start with 2. So 48 is it divisible by 2? Ends in an 8, so it is divisible by 2. 31, nope. 834, yep. 540, yep. 7212, yep. 135, nope. All right, new color for the 3s. So now we're going to do that adding the digits thing. So 4 plus 8 is 12. And you could even 1 plus 2 is 3. So it's divisible by 3. Now 3 plus 1 is 4, not divisible by 3. Then 8 plus 3 plus 4. 3 and 4 is 7, plus 8 is 15. So this one is divisible by 3. 5 plus 4 plus 0 is 9. So this one is divisible by 3 and is in fact divisible by 9 as well. Now let's see here. 7, 8, 9, 10, 11, 12, divisible by 3. 135, 1 plus 3 is 4, plus 5 is 9. So this one is actually divisible by 3 and 9. Now note, to determine if it's divisible, I don't have to actually know what the other part would be. I just have to follow the rule, have my rule. There is nothing wrong though, just with crunching it on the calculator. Is this divisible by 2? Is it divisible by 3? Is it divisible by 5? Your job is to know, what does it mean when we ask about, is a number divisible by something? Does it divide in nicely? Okay, so don't stress yourself out if like looking at those rules and memorizing them is like, I don't think I can do it. Remember what divisibility means. And remember, I will give you plenty of time on any assessment. All right, so we got to check 5s now. Not a 5 or 0, not a 5 or 0, not a 5 or 0, 0. Here it is. This one is divisible by 5. Nope, 2, but another 5, also divisible by 5. And then last one, there is only one of these that ends in a 0 because it is the only one that is divisible by 2 and 5. Random chance that I managed to pick red, blue, and purple there, but hey. All right. On Alex, this should be like, it's numbers and then it's columns where you check, is it or not? So it'll be like, if it's divisible, put a check. If it's not, leave it alone. Totally legit to have like one check show up in a grid of 9 boxes. Because I think they only do 2, 3, and 5. I don't think they do 10. So don't freak yourself out if you're like, well, none of these were divisible by 5. It happens. The computer literally picks random numbers. So it can totally happen. In fact, I wouldn't be surprised if there's always at least one that wouldn't be divisible by anything they're asking about. Now 11, we have let's write a word problem. So Alina baked 129 cupcakes for her 43 guest party. Can Alina's guests enjoy evenly the cupcakes? No, because out of 43 guests, at least 3 of them are going to be piggies and grab extra cupcakes when no one is looking, because you can't get 43 people around the table. So in reality, this is a silly question, but in math land, everyone is nice. Everyone will go and take one. And they make sure everyone has one, and then they go and take 2. And they make sure everybody got a second one, then they'll go take 3. Make sure everybody got a third one, and then everybody in math land likes things to be the same. That is not always a good thing, but when we're talking about math word problems, they exist in math land where we don't talk about real worlds. Real rules, real world. I put those 2 together. That did not work. All right, so 129 and 43. So evenly means how many whole cupcakes can each person eat, and would there be any left over? So 129 is not even, but let's see what it is divisible by, because if I can break it into a smaller pair, I can see what the other number is made up of and kind of work through my pairs there. So 1 plus 2 is 3 plus 9 is 12. It is divisible by 3. 3 goes into 12 4 times, or goes into 120 40 times. And then 3 goes into that 9 3 times. Oh, so how many cupcakes does everybody get? Yes, everyone gets, they can evenly split. They're all going to get 3 cupcakes. All right. So let's pause it here, and then we'll come back in the next video with the prime factorization.